Okay, hello everyone. In our last class, in detail with note, we have been discussed about translational matrix for divergence of ray and convergence of ray. In vacuum, we found for divergence of ray, translational matrix is this one, and for convergence is this one. I suggest you just remember these two matrices, or you can remember these two matrices in general. If any medium, if we are going to consider, then it will be T by mu, and here minus T by mu. In this class, we are going to discuss reflection matrices by different mirrors. First, we are going to discuss reflection matrix for concave mirror, then convex, then for plane mirror. Okay. Yes. Here I am going to suggest once again to you that, see, if I'm going to follow your syllabus, this is your syllabus, translational matrix, reflection matrix, refraction matrix, these matrices directly not mentioned here. It is mentioned only we have to discuss the matrix formulation of geometrical optics. Geometrical optics means what? Translation, reflection and refraction. Translation last class we discussed. In this class we are going to discuss reflection matrices from different mirrors. Next class we are going to discuss refraction matrices. Okay, so let us start here. First we are going to discuss reflection by concave mirror. Here this is the figure that we have to follow to find out the reflection matrix. Consider a ray of light travels in vacuum from point O to A. Here O is represents the object, suppose. Okay, and O to A, it is traveled from O to A. This is the concave mirror. This side is your polished surface, so light will reflect from A, and this side is the opaque side. Okay, so then first it will travel from O to A, then reflected from the point A. From here it will be reflected and converged at the point I. So I means so-called image. So here O represents the object information, I represents the image information. So what will be the matrix, the how we can represent this dynamics or reflection in matrix form? Here I am going to discuss. You have to write in your own note for your exam point of view. Here R is the radius of curvature and C is the center. See, if I am going to consider this concave surface, this is the so-called its circular geometry, and this is from this point to this point, from C point to surface, or you can say from C point to A point. This is the radius of this curvature or this circle, the so-called circle of this curvature. Okay, so this from C to A distance is your R, or we can say the radius of curvature is your R, and C is the center. Here C is the center. Okay, from figure theta 2, here theta 2 equal to beta plus alpha. Here theta 2 angle equal to beta plus alpha. Theta 2, where is theta 2? This is the theta 2 is your beta plus alpha, because if I am going to consider this triangle CIA triangle, then theta 2 is the outside angle, so obviously theta 2 is the sum of these two internal angles, so alpha, beta plus alpha, whatever written over here. And beta, if I am going to consider beta is the sum of these two angles, theta 1 and alpha. Okay, so as the ray reflected from A, this angle is so called your incident angle, this is your reflected angle. So if this is your alpha, this is also alpha angle. If we are going to consider this triangle COA triangle, then this angle is the outside angle, so beta will be equal to theta 1 plus alpha, whatever written over here. This must, see, whatever I written over here, this is enough for your exam point of view. If this question will be asked, suppose in your exam, this much you have to write, this is enough. No need to think about your note, what you are going to write in your exam, etc. Don't, this is enough. Okay, that implies here, if I am going to consider here theta 2 is equal to beta plus, instead of alpha, what I can write, beta minus theta 1, beta minus theta 1. That implies theta 2 will be equal to here beta plus beta 2 beta minus theta 1. Let this is your equation number 1. Now consider right angle triangle CAM. Here C, this is your A, this is your M. this triangle, consider this triangle, this is your 90 degree. Okay, for this triangle, if I'm going to consider tan beta, beta is here, tan beta, then tan beta will be am, this height am by mc, this distance. Okay, am by mc. For small angle, we know for the small angle tan beta is nothing but your beta is equal to am by mc. Am, here we consider am, this height or this distance is equal to y1, and mc, here m to c, here m to c considered as minus r. Why minus r? First you just focus over here, r means here we consider radius of curvature. How this mc distance will be r? How? If I'm going to consider this beta angle is very small, see this is the beta angle and this reflected from a. If I'll decrease this angle, then this a point will be shifted over here. If I'll again decrease this beta angle, the a point will be shifted over here. Okay, so if it is so, then see, if a point will be here, then here you can see am point will be shifted towards this, towards right side. So here cm will be approximately r when beta is very small. Only for that we considered mc magnitude is your r. Why it is minus? Because according to sign convention, if we are going to move this side, it will be negative. If we are going to move this side, it will be positive. Okay, if we are going to move, this is your principal axis. Okay, if we are going to move upward from the principal axis, positive. If we are going to move downward, it will be negative. Okay, another thing also you have to remember, angle also follow the sign convention. If we are going to consider from the principal axis, this c, if I'm going to consider theta 1 and beta and theta 2, all are measured from the principal axis by considering what? Anti-clockwise. So anti-clockwise, whenever we are going to consider, that will be considered as negative. If we are going to consider clockwise, somewhere if we are going to measure the angle clockwise from this principal axis, then that will be positive. Okay, that we are going to discuss in our next slide or next topic, whenever we are going to discuss about the convex mirror. Okay, so beta value we found y1 by minus r. Now we have to put this beta value in equation number 1. You just put this value y1 by minus r instead of beta. So what we can get? Theta 2 is equal to 2 into y1 by minus r, 2 into y1 by minus r, minus I written over here, and minus theta 1. Or we can write theta 2 is equal to minus 2 by r into y1 plus, here minus can be written as minus 1 into theta 1. Let this is your equation number 2. Okay, see here I not considered the sign convention for theta 1 and theta 2, because if I'm going to consider the I'll get the same answer. How? See here theta 2, here theta 2 anti-clockwise I have to consider as negative. Okay, here theta 2 I'll consider as negative. Beta also traverse anti-clockwise negative, and theta 1 also negative. So by considering common factor negative, also we can get the same equation number 1. So I not written over here those things. So about anti-clockwise and clockwise convention, that we are going to discuss in our next topic, when convex, for the convex mirror. So here we found equation number 2. Again from figure, y2 equal to y1. Here y2 equal to y1. See, y1 is represents for the incident ray, y2 is the height for the reflected ray. For incident ray, that means for OA ray, this point, and for AM ray, this A point is common. So for OA ray or for the incident ray, this height is equal to for reflected ray AI ray, that is y2. That means for incident and reflected, this height is common. So only for that y1 equal to y2. So from figure y2 equal to y1, see y1 represents the information about incident ray, y2 represents the information about reflected ray from the common point A. Okay, so if I'm going to write this equation y2 equal to y1 in this format, there is no wrong. I can write y2 equal to 1 into y1 plus 0 into theta 1, same thing. Let this is your equation number 3. Now the equation number 2, this one, and 3 can be written in matrix form as here, like this. y2 theta 2 is equal to 1 0 minus 2 by r minus 1 y1 theta 1. Why? We just written the coefficients. By considering the coefficient, this matrix is nothing but the coefficients of y1 and theta 1. See, y2 theta 2 here, y2 theta 2, left hand side I written in the form of 2 cross 1 matrix. Then coefficient here, this coefficient y1 coefficient is 1 written over here. Okay, and here y1 coefficient is your how much, minus 2 by r, minus 2 by r. Here theta 1 coefficient is 0 written over here, and here theta 1 coefficient is minus 1 minus 1. This is your 2 cross 2 matrix into y1 theta 1, again this is your 1 2 cross 1 matrix. So from this matrix form we can write these two equations. Here you can see y2, if I'm going to consider y2, then this row multiplied with this one, that means we can get y1 1 into y1 plus 0 into theta 1. Okay, then again theta 2, how much we can get, this row into multiplied with this column, minus 2 into r y1, here minus 1 into theta 1. So this is the representation of a matrix form of these two equations, right? Right. Here this 2 cross 2 matrix is called as your reflection matrix. In short, it is written as M subscript M. For concave mirror, MM or reflection matrix is nothing but your 1 0 minus 2 by r minus 1. Okay, now we are going to go for reflection by convex mirror. So this is the convex mirror, this side is your reflecting surface and this is the opaque surface. Okay, so here this is the object information, and this is the virtual image information, because the incident ray coming from O and reflected at A, after reflection it moved in this way. If I will join this reflected ray backward, then I can get this I point. So this I represents the virtual image of this object. So for if I'm going to consider object information is nothing but your theta 1 and this height is your y1, and image information is your what, is your this one theta 2, this theta 2 and y2. Here both y1 and y2 are same height. Now I'm going to consider this dynamics of this reflection, and we are going to find out the reflection matrix. Same thing I have been written over here. In this case, a ray of light reflected from convex surface and diverged like this, but it is virtual image will be formed at I, whatever I discussed. R is the radius of curvature. If I'm going to consider a circle by considering this curve, this is the circle, and this will be the radius. A to C is the radius R, and this is the center. Okay, R is the radius and C is the center of the curvature. From the figure, if I'm going to consider AIC and AOC triangle, first you consider AIC triangle. This is your AIC triangle. Theta 2 means outside angle, this one. Theta 2 equal to sum of these two angles, alpha plus beta. Here I written beta plus alpha, same thing, beta plus alpha. And if I'm going to consider AOC, AO and C triangle, AOC triangle, alpha means this angle, this is the incident angle and this is the reflected angle. Consider this triangle A, O and C. Outside angle is your alpha. This alpha angle is the sum of theta 1 and beta. Same thing, it has been written alpha equal to theta 1 plus beta. So that implies theta 2 is equal to, instead of alpha, if I'll be put theta 1 plus beta, then we can get 2 beta plus theta 1. From figure, it can be noticed that angles theta 2 and beta generated by clockwise rotation from principal axis. Clearly I written theta 2 and beta here. Theta 2 this angle and this angle. So this is the principal axis. So these two angles can be generated by clockwise rotation, like this clockwise rotation. So I told that whenever we are going to consider clockwise rotation, at that time the so-called sign convention is your positive. For anti-clockwise it is negative. So for theta 1, if I am going to consider, it will be generated from the principal axis by considering anti-clockwise rotation. So theta 1 will be considered as negative, whereas theta 2 and beta will be the positive. Hence the above equation will be, above equation means this one, theta 2 is your theta 2 and beta, wherever the theta 2 and beta, that will be the positive as compared with the theta 1. Theta 1 is your negative. Let this is your equation number 1. Now consider the right angle triangle AMC. A, M and C. AMC, this is the 90 degree. For this triangle, tan beta will be how much? Tan beta will be this height, A to M minus, A to M by MC, AM by MC. If this angle will be small, that means the A point will be moved towards this side, towards downward. That means if I'm going to consider this one, this angle, means I reduced or decreased this beta value, that means A point will be here. So M point will again be moved towards the surface of this convex mirror. That means by considering the small angle, this MC distance is equivalent to R, right? So as we are considering this side, so this side, from this surface to this side, we are considering the length. That means we are considering towards the right side. Towards right side means sign convention is your positive. So MC, or for small angle beta, this distance will be R, but according to sign convention it will be positive. So for small angle, beta will be equal to AM by MC. AM, this height is nothing but so-called Y1 by plus R. Now put this beta value in equation number 1. Here, instead of beta, we have to put this one, Y1 by R. We can get equation number 2. Theta 2 is equal to 2 by R into Y1 plus, here, theta 1 minus theta 1 can be written as minus 1 into theta 1. Let this is your equation number 2. Again, from figure, what we can get, this height. That means for image information, the height Y1, for object information Y1, for image information this height also, this height is Y2, and both are same, Y1 equal to Y2 or Y2 equal to Y1. This Y2 equal to Y1 equation can be written as Y2 equal to 1 into Y1 plus 0 into theta 1. Let this is your equation number 3, right? Now again I written these two equations in this slide. So we found equation number 2 and 3. Now we are going to write these two equations in matrix form. How we are going to write? Y2 theta 2, here Y2 theta 2, we are just write the coefficients 1 0 1 0, here Y1 coefficient 2 by R, theta 1 coefficient minus 1 into Y1 theta 1. This is your 2 cross 1 matrix, this is your 2 cross 2, and this is your 2 cross 1 matrix. From this matrix representation, we can found Y2 and theta 2 in this polynomial form. Okay, so here this 2 cross 2 matrix is called as the reflection matrix from convex mirror, okay, which is represented by M. See, when we are going to consider the reflection matrix, that is represented by M subscript with a small m. Here I not written, I'll correct it. So here reflection matrix, that may be for from concave and convex mirror, it is represented by M subscript with a small m. For convex, the matrix, reflection matrix is this one. If I am going to compare with concave mirror, whatever we discussed just now, this one, here 1 0 minus 2 by r minus 1. By comparing this and this term is minus here in case of concave, otherwise other terms are same. Okay, so here now in general the reflection matrix, that is your m subscript m, by concave or convex mirror in a medium, if I'm going to consider having refractive index mu, then the value will be like this: 2 mu by r, plus or minus, because for concave it is minus, for convex this term is plus. So why it is 2 mu by r? See, for any medium, see here the distance means, here we are considering this one. For convex mirror we are considering the radius of curvature towards this side plus, for concave we are considering radius of curvature this side r. For free space this is the distance. For a particular medium हम refractive index, that this length will be r by mu. So here instead of r we have to write what? R by mu. Here we have to write r by mu. So r by mu means mu will be moved up to the numerator, so it will be 2 mu by r. So for vacuum or free space it will be only 2 by r, 2 by r, but for concave it is minus, convex it is plus. Okay, I suggest you just remember in general the concave or convex mirror, the reflection matrix is this one: 1 0 plus or minus 2 mu by r minus 1. For free space automatically the mu will be 1 and this will be plus or minus 2 by r. For plus is for your convex, minus for your concave mirror. Now if I'm going to consider for the plane mirror, see, for a concave or convex mirror we have a radius of curvature, definite length. For this one, this is the radius of curvature, this length, or you can say this length. And for convex, this length is the radius of curvature, or you can say this length is the radius of curvature. But you just imagine if this mirror, this concave mirror will be flat like this, here I represented, or the so-called plane mirror, what will the radius? Radius will be at radius, the length of the radius will be infinite. Okay, you just imagine here, if we are going to consider instead of convex or concave plane mirror, the radius of curvature will be infinite, so r will be infinite. So in general we found this expression: concave or convex mirror, the reflection matrix is this one. For plane mirror r value will be infinite. If I will put over infinite over here, so this term will be 0, right? Same thing I have been written over here. In case of your special case, whenever we are going to consider reflection by plane mirror, this figure r is your infinite, and this term here instead of r we have to put infinite, and the reflection matrix m will be equal to 1 0 0 minus 1. I suggest you remember this one, this matrix, and this matrix, okay? These three matrices are required in our forthcoming classes. Okay, so here I am going to stop this class. In our next class we are going to discuss refraction matrices by different surfaces. Thank you so much for watching this video. Thank you.